Hey everyone, today we're going to learn how to calculate the slope of a line when you're given a graph of that line or 2 points that fall on the line. So, quick review of what slope is. So slope is the constant rate of change between points on a line. So how do I get from one point to the next point? Okay. Slope is also defined as a ratio, frequently presented as a fraction, of the vertical change how you move up and down from one point to the next, which we sometimes call the rise. And then we're comparing that to the horizontal change. Okay, that's how I move side to side as I go from the line. We frequently call that the run. Okay. Usually we use the variable m to represent the slope. Okay, so it's a ratio or a fraction that compares the vertical change, the change as I move up and down, to the horizontal change. How does it change as I move side to side? So just a quick refresher that there are 4 types of slope. And if we look visually at what the graph looks like, it becomes very easy to classify these types of slope. So the first type of slope is when I'm traveling left to right along the line, and that line is going up as I move left to right. It's rising as I move from left to right. So that may go slowly like we saw in this first example, or it might be a little steeper like we saw in the second example. Again, it's rising as I move left to right. That is called a positive slope. And when you have a positive slope, you can tell by the graph, but also the number itself, the numeric value that you find for your slope will be a positive number. Okay. Conversely, we also have a negative slope. As I move left to right on the line is falling. Again, it might be really steep, like we see in this first example, or it might be more gradual, but as I move left to right, I'm going down and down and down and down. This again is called a negative slope. Okay. Just like with a positive slope, the numeric value of a line, of the slope of a line that has negative slope, is actually going to have a negative number. So you may have -5 or -4/2, but either way, if your line is going down or falling as you move from left to right, you are going to have a negative value for your slope. Okay. We also have 2 special cases, and we're going to get into this more at the end of this lesson, but we do have 2 special cases. So when I have a horizontal line, or a line that only goes side to side, I don't have a positive slope or a negative slope. It doesn't rise as I go from left to right, like a positive slope does. It doesn't fall as I go left to right, like a negative slope does. In fact, it doesn't do either of those. So this one is called a zero slope. And numerically, you are actually going to get that m is equal to the value 0. Okay, we'll talk a little bit more about that as we get close to the end of the lesson, but horizontal lines that go side to side will always have a slope of 0. Similarly, when I have a straight up and down line or a vertical line, vertical lines have a really special slope called an undefined slope. Okay. When you calculate the slope, you will actually find that m is undefined. Okay. If you put it in your calculator, you'll get an error, or it may straight up say undefined like Desmos will. Again, we're going to get more into what those 2 mean at the end of the lesson, but I wanted to talk really quickly about the 4 different types of slope. Positive, if it rises as you go left to right, it goes up. Negative, if it goes down as you go from left to right, and then 0 and undefined. All right, so now that we kind of understand our slopes, we can calculate those slopes based on the graph that they give us. So our first step is going to be to find 2 points on the line. Okay, sometimes they'll give you those 2 points, like in this example, they give us this point, and that's great. But the benefit of this is that you can use any 2 points on the line. You can use the ones they give you. You can come up with your own. It doesn't really matter. The only rule is that those points need to be on the corner of the coordinate plane. Okay, so if I've got my coordinate plane here, I don't want to use a point that's like this one, where it doesn't really fall on the corner of a box. It's kind of in the middle of that. Instead, I'd want to use a point kind of like this one, where that point falls on the corner of the grid line. Okay, choosing points will get easier as you practice this more, but as long as your points fall on the corner of a grid line, you can use those. Okay. Once I have my points, I'm going to find the vertical change, or the up and down change, which we call the rise. Okay, so your rise is how your line changes as you move up and down. Okay, now with your rise, we have to be able to note direction. Am I going up or am I going down? And the way that we're going to do that is that we're going to use positive numbers for upward movement, and we're going to use negative numbers for downward movement. So if with my rise, if I'm going upwards, I'm going to use a positive number to represent that rise. If I'm going down, I'm going to use a negative number to represent the rise. Okay. So in this case, I'm going to start with either point. It doesn't matter. I personally like to start with the point that's on the left. So I'm going to figure out my rise. I need to go down from here to get to this point. Okay, I need to go down. If I go up, I'm not going to arrive at this point over here. So I'm going to go down 1, 2, 3 spaces until I'm in line with that other point. Okay, so my rise is -3 because I have to go down from there. The next thing I'm going to do is I'm going to calculate the horizontal change. Which we sometimes call the run. Okay, our run is how you move side to side from one point to the next. So I know that I moved 3 down. Now I have to figure out, am I going to go left or right to get to that next point? If I'm going to go to the right, I want to use a positive number. And if I go to the left, I want to use a negative number. Okay, so my run is the change left or right. If I go to the left, I'm going to use a negative number. If I go to the right, I'm going to use a positive number. So from my place right here where I finished calculating my rise, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces until I get to my next point. So my run here is going to be 9. Okay, we found that the rise was -3. Once I have my rise and my run, all I have to do with that is write it as a fraction, with rise being in the numerator on the top and run being the denominator on the bottom. So I'm going to set that up as a fraction of rise over run, and then I'm going to simplify that. Fortunately for us, simplifying is pretty easy to do when we have Desmos. So I'm going to set this up as rise over run. So m equals the rise, which was -3, over the run, which we found was 9. And now all I have to do is simplify that. Again, we can do that in Desmos. So remember that you can open up a fraction on Desmos by pressing the dividing button first. I'm going to put my rise, -3, on the top, and my run, 9, on the bottom. Now, Desmos automatically gives me a decimal, but when we're working with slope, we want to use fractions. So I'm going to click this button right here on the Desmos interface, and that's going to let me change my decimal into a fraction. Okay, so my reduced fraction here is -1/3. Okay, so the slope of this line is -1/3, and that checks out with what the line looks like, right? As I go from left to right on this line, it's going down as I move from left to right, which means that my slope is going to be negative. We talked about that up here. And that makes sense because I do get a negative number when I calculate that slope out. let's try the second one together. I want to find 2 points on my line. Fortunately for me, they've already given me the points that I need. I'm going to use this point and this point, okay? If you were to pick your own points, you can do that. You just need to be careful, okay? So for this one, I'm going to start at this point and move to that point. So I'm going to calculate my rise first. Remember, the rise is the change up or down. If I go up, I'm going to use a positive number. If I go down, I'm going to use a negative number. I like to start with the point on the left. So I'm going to go up 1, 2. So my rise is a positive 2. Then I'm going to find my run. How do I move from side to side? Remember, if I go to the left, I want to use a negative number. If I go to the right, I want to use a positive number. So from here, I'm going to go 1, 2 to the right, which is a positive 2. So my run is positive 2. Now all I have to do is set up that fraction, rise over run. My rise was 2. My run was 2. And now I'm going to simplify that in Desmos. Again, I can open up a fraction by pressing the division button. 2 is my rise on the top. 2 is my run on the bottom. And then it simplifies there to 1. Again, this is a positive slope, which I can tell by looking at the line. As I move left to right across the line is rising, it's going up, which means that I should get a positive number, like 1, as my answer. Okay, so with that in mind, go ahead and do numbers 1, 2, and 3 on your own. Okay, remember that you're finding your 2 points, finding the rise, finding the run, and then writing that as a fraction, rise over run, and simplifying. Okay, do this work on your paper. You can pause the video, calculate this out, and then come back here and check your answers with my answers. All right, for number 1, you should have gotten that 4 was your rise, 1 was your run. 4 over 1 reduces to a slope of 4. Number 2, your rise was negative 2 because I went down. My run was 4, and then that reduces to rise over run, gives me negative 1/2 as my slope. And then number 3, my rise is 2 because I went 2 up. My run is 2 because I went 2 to the right, and then I calculate that to equal 1. Okay, if you have questions on that, make sure you write them down. We'll address them in class. Okay. So now we're going to switch gears a little bit, and we're going to talk about how to calculate slope when they give you 2 points on the line. So rather than giving you a graph with the points indicated, instead, these ones are going to give you where those points are located. So for example, this one is at -1, -2, -3, -1. So this one's at -3, -1. This one is at -1, 1, excuse me, -1, 1. So rather than give you a line or a graph of that line, they're going to give you the coordinates of 2 points on those lines. Fortunately for us, all we have to do with those coordinates is plug them into this formula. So with this formula, I'm taking my 2 ordered pairs. So here's my first one and here's my second one. And from those, the x from my first value we call x1. Okay? The y from my first point we call y1. The x from my second point is called x2, and the y from my second point is called y2. Okay. Once we have those values, we're going to plug them into this formula. And this formula reads y1, so the y from my first point, minus y2, which is the y from my second point, over x1, x from my first point, minus x2, x from my second point. Okay, once I've plugged those in, all I have to do is calculate. So the first thing I want to do is identify which values are my x1, my y1, my x2, and my y2. Okay, so remember, the x value in my first point is called x1. The y value in my first point is called y1. The x value in my second point is called x2, and the y value in my second point is called y2. Okay, So the first thing I want to do is just label those. Second thing I want to do is actually plug those numbers into the slope formula, which we just talked about up here. Okay. When you're plugging those in, be sure to use parentheses and be sure to be careful of negatives. Okay, or of signs. Let's write signs. Okay. Making sure that you're being careful with, is this a 2 or a negative 2? Okay, positives or negatives. Being careful with those. Okay, so here's my slope formula. Y1 is this 4 right here. So I'm going to plug in that 4 with parentheses. Minus Y2. Y2 is negative 2. So I'm going to plug in negative 2, again, with parentheses. Then I've got x1 minus x2 on the bottom. x1 is negative 2. I plug it in with parentheses. Minus x2 is 10. Again, I plug it in with parentheses. Okay. Fortunately for us, all of this is the hard part of this process. Because from here, I'm just going to evaluate and simplify my fraction. And that's a really fancy way of saying calculate it out. Okay, so I'm going to evaluate and simplify. But fortunately, we already know that Desmos will do this together at the same time. So all I have to do once I plug this in is then plug it into Desmos. Okay. So again, I'm going to open a fraction by pressing the dividing sign. And then I'm going to type exactly what I see. Parentheses 4 minus parentheses negative 2. And then on the bottom, negative 2 in parentheses. There we go. Minus 10, also in parentheses. Again, it wants to give me a decimal to start with, but I don't like decimals when I'm working with a slope, excuse me. So I'm going to press this button and turn it in to a fraction. Okay, this will reduce to negative 1/2. Okay. Let's try another one. Work through this one with me. Remember that we're going to start by plugging our values into the slope formula. So m equals y1 in this case. I got to label them first. That will help. So 10 is my x1, 0 is my y1, negative 2 is my x2, and 4 is my y2. Okay, remember x from the first, y from the first, x from the second, y from the second. Now that I've labeled these, I can plug them into my formula. y1 is 0. Again, we use parentheses to plug those in. Minus y2 is 4 over x1 is 10 minus x2 is negative 2. We use parentheses all the time. Then all I have to do is plug this into Desmos. Division sign to open up the fraction, parentheses 0 minus parentheses 4, and then on the bottom, 10. I need parentheses around that. Minus negative 2 also in parentheses. Again, it wants to give me a decimal, but that's not a problem. I'm going to switch it to a fraction, and I'm going to get that m is equal to negative 1/3. Okay. With that in mind, go ahead and try 1, 2, and 3. Pause the video, copy this on your paper, work it out, and then come back here and check your answers with my answers. All right, so for number 1, you should have gotten negative 3. For number 2, you should have gotten 3/5. And for number 3, you should have gotten negative 7. Okay. If you didn't get these correct, make sure you write down your questions so that we can go over them in class. All right, so at the beginning, I mentioned that we would be coming back to our special cases to talk about them just a little bit more. So remember that graphs of horizontal lines only go side to side. Okay, they don't go up or down at all. They just continue straight in a flat way. Remember that the slope of these lines is 0. And I'm going to mathematically show you why that is here. So from my graph, here's my horizontal line. I've got my 2 points here. And I can still try to do rise over run to find the slope. So if I start at this point, I do not have to rise at all. I don't have to go up or down any to reach my second point. So my rise here is actually 0. Okay. My run, on the other hand, in this case, is going to be 1. I go 1 to the right. So when I write my ratio for my slope, I'm writing my rise 0 over my run 1. Okay, 0 over 1, and if I do this in Desmos, you'll see this as well. 0 over 1 is equal to 0. Okay, so when you reduce this down, you actually get 0 as your slope. Okay. I can see this when I do it mathematically or calculate it out with the formula as well. So I've got x1, y1, x2, y2, meaning that this slope is going to be 9 minus 9 over 5 minus 3. 9 minus 9 is 0. 5 minus 3 is 2. But also if I just put this whole thing in Desmos, 9 minus 9 over 5 minus 3, I'm still going to get 0 as my slope. Okay. If you wanted to see another example, this one will do the same thing. Okay. So you'll get 0 as your value on a horizontal line. Vertical lines, on the other hand, go straight up and down. Okay. They don't move side to side at all. They just go straight up and down. And we talked earlier about how the slope of these lines is undefined. Okay. If I'm looking at a graph, I can start with my 2 points. My rise in this case is 1, 2, 3, because I go 3 up to get from one point to the next. And then my run, I don't have to move side to side at all because I'm already on that point. So my run here is 0. Now, if you're familiar with math, you know that when I write this ratio, I get 3 over 0, which is kind of a problem. I can't divide by 0. Mathematically, it doesn't work, okay? Which is how we get the slope being undefined. I cannot divide by 0, so I cannot give this slope a definite value, okay? Fortunately for us, when I do this with the, slope formula, so x1, y1, and x2, y2, I get 8 minus 5 over negative 7 minus negative 7. When I put that in Desmos to calculate it, eight minus 5 over negative 7 minus negative 7. Desmos will actually tell you that it is undefined. Okay, so you can write, you can abbreviate it if you want to. If you do this in a calculator, you may get error. It may say error here instead of undefined, and that's okay. The slope is still classified as undefined for these problems. Okay, if you want to see another example of that, you can do this second set of ordered pairs. But otherwise, if you have any questions about any of the stuff we covered in this video, make sure to bring them to class and we'll answer them next time.